Hello everyone, welcome back, and today we will discuss about the ruby laser, right? And it is a solid state laser which consists, or any laser will consist mainly three parts. One is the working material, second one is the optical resonant cavity, and third main part of laser is the excitation source, right? So what is working material can be defined as the material whose population inversion to be achieved, right? And excitation source can be defined as by the process we are going to achieve the population inversion. So this excitation source is used to achieve the population inversion. And this optical resonant cavity is a system of two plain flat and parallel mirrors whose ends are fully silvered and partially silvered. So this is about the main part of any laser. Right now in ruby laser we also have these three main parts. So let's talk about these main parts. And first one is the working material. Ruby laser is made up of a crystal of ruby in the form of cylindrical rod, right? And the dimension of this rod is having size of 2 to 30 centimeter in length and 0.5 to 2 centimeter in diameter, right? So this is figure of a ruby laser. And the length of this rod, this is ruby rod, okay? This is ruby rod. So length of this rod is 2 to 30 centimeter and diameter is 0.5 to 2 centimeter, whose both ends are optically flat. Now these ends are optically flat. This is fully silver surface and this is partially silver surface, okay? So they can act as fully and partially reflective surfaces. Now ruby rod is a crystal. And now what is the composition of this ruby rod? So ruby rod is a crystal of Al2O3 which is mixed with the impurities of chromium ions, okay? And these ions will replace some of the aluminum ions in Al2O3 crystal. So these impurity chromium ions give rise to the laser action. And the space between the two faces A and B, let's say this is phase A and B, is known as the resonant cavity, in which the light intensity can be built up by multiple reflections and through stimulated emission, okay? The rod is bound by helical xenon flash tube lamp. It means this is the excitation source. So the excitation source is helical xenon flash tube lamp. This will work as a resonant cavity, okay? And this rod is a working material. So the ruby rod is bound by helical xenon flash tube lamp. So the excitation source in case of ruby laser is helical xenon flash tube lamp. Now let's talk about the construction of this ruby laser. Okay, so the ruby laser consists of a ruby rod. A ruby laser is consist of a ruby rod, as we have discussed, and which is made up of chromium ion doped ruby material, which is Al2O3. At the opposite end of this rod there are two silver polished mirror whose one end is fully polished and other is partially polished. Around the ruby rod, flash tube is kept for the pumping, and the whole assembly is kept into a glass tube which is named as resonant cavity. So this is the construction. Now let's talk about the working principle of ruby laser, which is very important. So this working principle, so under this working principle, the chromium ions are active centers, as we know that, because we are doping chromium ions in Al2O3. So chromium ions are active center in this ruby laser, which are responsible for the laser transition. And this is the energy level diagram of a ruby laser. And this energy level diagram can explain as when you just switch on helical flash light tube, this one, when you just switch on this one, the photons are absorbed by the atoms of this ruby rod. So once photons are absorbed, the electrons from the ground state of this ruby rod will move to the excited state. So these electrons will started moving towards the excited state, and this is our excited state, right? And this is ground state. Okay, so as we know that this state is very unstable state whose lifetime is 10 raised to minus 8 second. The electron will not continue at this stage for longer interval of time. It will jump back to the lower state, and thus ruby laser is 3-level state, 3-level laser. So ruby laser is a 3-level laser. It will jump back to the lower state, and the lower state is a metastable state whose lifetime is 10 raised to power minus 3 second. Okay, now this metastable state is little bit stable or more stable than excited state, but less stable than ground state. This electron will jump back to the ground state again and will release a photon. Okay, now initially this process is spontaneous emission initially. Now where this photon will go? So this photon, due to this fully silvered surfaces, it will reflect and strike with the atoms who are already present in excited state, because this xenon flash tube light is a continuous source, because it is continuously raising the electrons from ground state to the excited state, and during the process that is followed by electron from E1 to E3, E3 to E2, E2 to E1. During this process some other atoms are already got excited. So when the photon is released, that is spontaneous emission is there, this photon will strike again. Let's say it is striking with this atom who is already present in excited state and achieve a population inversion, that is n2 greater than n1. So when this photon strike with the atoms who are already achieved this population inversion condition, then we can say that there is a spontaneous emission. Okay, so this is the working principle of ruby laser, and the same thing we have write on here, that in this laser chromium ions are active centers which are responsible for the laser transition. So in the normal state most of the chromium ions are in ground state, that is E1 state. When light from the flash tube of wavelength, so what is the wavelength of this flash tube, 550 angstrom, is made to fall upon the ruby rod, these incident photons are absorbed by the chromium ions that rise to the excited state E3. Then they give a part of their energy to the crystal structure. It means a very small part of their energy will given to the crystal structure and reach to the metastable state. Okay, that is E2 state. The ions in the metastable state can remain for longer duration, which is 10 raised to minus 3 second. Therefore the number of ions in the state goes on increasing, while the same time number of ions in the ground state goes on decreasing. Okay, due to this continuous optical pumping. So thus the population inversion is established between metastable state and ground state, and when an excited ion passes spontaneously from the metastable state to the ground state, it emits a photon, right, which is having a wavelength 6943 angstrom. This photon travels parallel to the axis of ruby rod and stimulates the surrounding ions in the metastable state. By stimulated emission, other photons are emitted. So this is the reason for stimulated emission, and these stimulated emitted photons are in phase with those of stimulating photons. Okay, so this is stimulating photon, these are in phase. So by successive reflections from this fully silvered surface photon at the end of the rod, every time the stimulated emission is achieved. Okay, so we obtain an intense coherent unidirectional laser beam from the partially silvered end, which is this one, right? So this is about ruby laser, and the energy level diagram is very important. there is always a transition from E1 to E3. E3 to E2 is radiationless transition because these states are close to each other. Electron will not get enough time to radiate. Then from metastable state to the ground state, and it will emit a photon. If the initial process was there, there is only a spontaneous emission, and by this continuous process we are getting a state when our population inversion is achieved n2 greater than n1. For this condition we can get a spontaneous emission which is responsible for laser action. And this is all about ruby laser. Thank you so much for watching this video.